Faster than the fundamental framework of spacetime itself, it possesses the capacity to remain aware of it. Consequently, it will gradually dismantle this notion, filling me with an increasing unease. At this very moment, our night sky is undergoing rapid transformations, and within the upcoming decades, perhaps even sooner, it could become entirely unrecognizable. Experts, including Neil deGrasse Tyson, have begun to raise concerns, acknowledging the inevitable changes brought about by the shifting of Polaris. The underlying reasons behind this shift are surprisingly unforeseen. Polaris, popularly known as the North Star, has been a reliable fixture in the sky for centuries, serving as a vital point of reference for astronomers, navigators, and stargazers. However, this could soon be altered, changing the way we perceive the heavens and our method of studying the universe. Let's delve into the implications this transformation could have for us. For centuries, Polaris has acted as a guiding light for sailors and astronomers, remaining steadfastly positioned in the sky. Its consistent presence has been crucial for navigation, but this stability may soon be upended. A paper published by the esteemed Royal Astronomical Society in September 2023 raised concerns about the future of this celestial marker. Polaris is entering a turbulent phase, one where it might eventually explode, vanishing from sight forever and drastically altering the sky as we know it. Before considering the possible outcomes of this event, let's take a closer look at the features specific to the star itself. Polaris stands out because it is close to the celestial North Pole. Positioned directly above Earth's northernmost point, it appears almost motionless in the sky. It resides within the Ursa Minor constellation, commonly recognized as the Little Dipper. Polaris shines with moderate brightness, resembling a yellow-white supergiant star, much larger and more luminous than our own Sun. However, Polaris is not a solitary star, it is part of a complex triple-star system. This system consists of Polaris A and Polaris B as a binary pair, with a third star orbiting them. The gravitational forces between these stars influence their orbits and behavior, and any disruptions in these interactions could lead to fluctuations in their brightness or pulsation patterns. Nonetheless, the precise nature of these forces remains largely misunderstood. Polaris is located about 323 light-years away from Earth, meaning the light we currently observe from it began its journey a long time ago. If Polaris were to explode, we wouldn't witness the effects for over 300 years. In fact, it's possible that Polaris has already exploded, but we simply haven't observed it yet. Throughout history, the North Star has held great cultural, navigational, and symbolic significance. Its constant position has made it an invaluable guide for ancient sailors navigating across seas and lands. Symbolically, Polaris has represented steadfastness and direction, remaining unchanged in the ever-shifting sky. For astronomers, Polaris has been a crucial reference point in studying stellar movements and variable stars. As a Cepheid variable star, its periodic changes in brightness have provided essential insights into the properties of stars and how variable stars behave. This characteristic has also been crucial for determining cosmic distances and calibrating scientific instruments, as its pulsations follow a predictable rhythm, making its behavior easier to forecast. Recently, however, Polaris has shown signs of deviating from its usual behavior. These irregularities in its pulsation cycle have piqued the interest of astronomers, calling for more investigation into the cause of these unexpected changes. Rather than adhering to its typical pattern, Polaris has begun to display erratic dimming, leading to concerns regarding the star's imminent end of its life cycle. This behavior aligns with what is observed in stars approaching their final stages. The gradual increase in Polaris's pulsation period, which was once steady, has been traced back to interactions within its star system. There has been a yearly increase of approximately 4.5 seconds in the pulsation period. While this may seem insignificant, it has notable consequences. Some astronomers speculate that the gravitational forces between the stars in the Polaris system could be influencing these changes in its atmospheric conditions, thereby affecting its pulsation patterns. Others are more concerned that Polaris is entering a critical phase that could lead to an explosion. The similarities between the behavior of Polaris and that of Betelgeuse, another prominent star in the Orion constellation, are striking. Both stars have exhibited complex variations in brightness, raising concerns that they may be nearing a dramatic explosion. Stars nearing the end of their life cycles often exhibit such irregularities before their demise. NASA has expressed more concern over Betelgeuse, but formal attention has yet to be fully directed toward Polaris. As a Cepheid variable star nears the end of its life, it undergoes several stages, including the red giant phase and, eventually, a supernova explosion. Given the irregular pulsations observed in Polaris, scientists predict that it is now in the stage of helium exhaustion, which is typical for giant stars approaching their end. These irregularities align with patterns seen in stars nearing the end of their life cycles. However, solid evidence of an impending supernova is still uncertain, and astronomers are continuing to monitor these anomalies to better understand the fate of Polaris. If Polaris were to undergo a supernova explosion, it would probably be a monumental event in the sky, potentially outshining the moon and remaining visible for days, weeks, or even months. Its brilliance could drastically alter our view of key constellations like the Big Dipper or Ursa Major, in which Polaris plays a crucial role. Fortunately, Earth would likely remain safe regardless of whether Polaris bursts into flames, due to its size and distance from us. While the explosion of Polaris might not be as visually spectacular as Betelgeuse's, it could still be visible to the naked eye for an extended period, outperforming nearby stars in this way. This would undoubtedly capture the attention of astronomers and observatories, generating widespread interest both in the academic community and among stargazers. However, the impact on Earth's environment or ecosystems would likely be less significant compared to a supernova closer to our planet. But what will happen to Polaris itself? What is its fate after a potential supernova explosion? First, it's important to note that while massive stars typically end their lives in a supernova explosion, this is not likely for Polaris. When a large star undergoes a supernova, its core collapses, causing a violent shock wave that disintegrates the star. However, Polaris is not large enough to withstand such a violent event. Instead, once it exhausts its nuclear fuel, it will shed its outer layers and transform into a white dwarf. This transition will not lead to a supernova but rather a quieter conclusion, as Polaris evolves into a small, incredibly dense stellar remnant. A white dwarf is the compressed core of a star of low to medium mass that has exhausted its nuclear fuel. This remnant, though roughly the size of Earth, will still have the mass of the Sun. Once this process occurs, we will no longer observe Polaris as we know it. Landscapes, in a similar vein, astronomers have used it as a fixed point for celestial measurements, enabling them to track the movement of other stars and determine distances in space with great accuracy. Should Polaris cease to serve this role, or worse, vanish entirely, it would pose a considerable challenge to both modern navigation and the field of astronomy. In terms of technological implications, the disappearance of Polaris would force a major recalibration of various astronomical systems. Telescopes and other instruments that rely on a fixed point of reference would require updates to account for the changes in the sky. This would extend to the myriad of systems and devices that rely on precise measurements of celestial positions, including global navigation systems. Satellites, which use a range of celestial bodies to ensure accuracy, might also experience disruptions, forcing a widespread overhaul of navigational technology. Culturally, the loss of Polaris would also be felt deeply. For thousands of years, this star has been a symbol of constancy, guiding not only seafarers and astronomers but also people from all walks of life who have looked to it for guidance. Many indigenous cultures have created myths and legends based on its steadfast position in the sky. The star's disappearance would, in many ways, symbolize a broader shift in how humans relate to the universe and could lead to shifts in cultural and spiritual practices centered around the stars. Polaris's eventual transformation into a white dwarf, while not as dramatic as an explosive supernova, still represents a significant end to an era. As the star sheds its outer layers and begins its slow, inevitable cooling process, it will no longer be visible to the naked eye. This will mark the end of an era for astronomers who have relied on it for centuries. However, the transition to a white dwarf will likely be a gradual one. While it may not offer the same explosive spectacle as a supernova, it will still be an event of profound significance in stellar evolution. The remaining stellar remnant of Polaris will not be able to sustain the same bright luminosity it once had, and its eventual cooling will make it less and less observable over time. What is particularly fascinating about this process is the insight it provides into the life cycles of stars. As we observe Polaris's changes, we are not just witnessing the end of a single star's life but also a key moment in the broader cycle of stellar birth and death. In many ways, Polaris's fate mirrors the eventual outcomes for many stars that go through similar life stages. Understanding these processes helps scientists predict the behaviors of other stars in similar situations and refine our understanding of the ultimate fate of our own Sunday. Interestingly, research into the pulsations and behavior of Polaris may lead to further discoveries in the field of astrophysics. Understanding the causes behind the star's erratic behavior could lead to breakthroughs in the study of stellar dynamics, which could, in turn, impact our understanding of how stars evolve over time. The pulsations of Polaris and other variable stars have long been a key tool for measuring distances in the universe. Through investigation into how these stars behave as they approach their final stages, scientists can refine those measurements and improve our understanding of cosmic scale. While some may view the disappearance of Polaris with apprehension, it is important to recognize that such cosmic events are part of a much larger process. Stellar evolution is ongoing, and the changes we witness in the sky result from natural processes that have been taking place for billions of years. Eventually, the change of Polaris into a white dwarf does not mark the end of our exploration of the stars but rather opens a new chapter in our understanding of the universe. As astronomers continue to monitor and study the anomalies surrounding Polaris, they will undoubtedly uncover more insights into the nature of stars and their evolution. In a sense, Polaris's fading from the sky would not be a singular event but part of a broader cosmic symphony playing out over millions of years. Other stars will continue to rise and fall in the night sky, taking Polaris's place as the focal point for navigation and celestial measurement. In the grand scheme of the universe, the loss of a single star is but a fleeting moment in the vastness of time, yet the impact on human history, both scientifically and culturally, would be profound. While the disappearance of Polaris may alter our view of the heavens, it would also encourage us to look deeper into the mysteries of the universe, to seek out new stars, and to develop new ways of understanding the cosmos. As the scientific community continues to monitor the changes occurring in Polaris, the importance of this research cannot be overstated. It represents a critical moment in our journey of discovery, pushing the boundaries of our understanding of how stars live, evolve, and pass away. Polaris's fate remains uncertain, and while the potential for a dramatic supernova remains speculative, the gradual changes it is undergoing offer a unique opportunity for scientists to study the processes that lead to the death of stars. Whether or not Polaris undergoes a final significant change, the knowledge gained from studying it will have lasting impacts on the field of astronomy. As astronomers continue to observe the star's behavior and gather data, they will contribute to a deeper comprehension of the forces that shape the universe. In turn, this knowledge will help refine our models of stellar evolution and enhance our capacity to predict the fate of other stars in our galaxy and beyond. The research on Polaris serves as a reminder that the universe is constantly evolving and that our place within it is but a brief moment in time. While the disappearance of Polaris might be an unsettling prospect for some, it is also an opportunity for humanity to embrace the ongoing quest for knowledge and discovery. Through continued study and observation, we will unlock new insights that will shape our understanding of the cosmos for generations to come.